Hi there, Mr. Sutton here with the IM3 Honors 1-2 Extra Practice number 3 solutions on operations and compositions of functions. For this problem, we're doing h plus g of x, which really means h of x plus g of x. So here's h of x, 2x plus 5, and to that we are just going to add g of x, which is x squared plus 4x. Don't need the parentheses, but I'm going to put them in there anyway. Just helps me kind of sort out what comes from where. And at this point, we're just combining like terms. So we have an x squared, that's kind of the highest term there. We can write that first if we want. And then a 2x and a 4x is going to add up to 6x. And then we have this 5 that doesn't have anything to get combined with. For this problem, we're doing g minus h of t. So that's g of t minus h of t. G of t is 2t minus 2, which I'll just put in the parentheses to keep it sorted out. And from that, we are going to be subtracting h of t, so subtracting 4t plus 4 in a parentheses. Let me drop these parentheses and distribute a little bit before I try to combine these. First parentheses I can drop for free. The next one, I've got to distribute a negative 1 to both of those. So negative 4t minus 4. A lot of people are going to miss that minus 4 there. Combining like terms, 2t minus 4t is negative 2t, and then negative 2 minus 4 gives us negative 6. For this problem, I'm doing g times f of x, so that's g of x times f of x, using the f and g functions here. So we have g of x, which I'll put in a parentheses, that's 2x minus 2. And I'm multiplying it by a parentheses with the f of x expression in there, 3x squared minus 2. Now I'm just going to FOIL this out and combine whatever like terms there are. So we have firsts, that's going to be 6x cubed. And then outers, 2x times negative 2, that's negative 4x. Inners is negative 2 times 3x squared, so negative 6x squared. And then for the last, it's negative 2 times another negative 2 is positive 4. So taking a look at this, we actually don't have any like terms. So this is actually an acceptable final answer. Or if you wanted, you could switch the negative 4x and the negative 6x squared around just to write things in decreasing order of degree. For this problem, I'm doing f over g of x. So that's just f of x over g of x. So we have 2x minus 3, that's f of x. And we're going to write that in a fraction over g of x, 3x minus 5. Now, at this point, if you can simplify, you should, but there isn't really anything we can do in terms of factoring and canceling out anything. This is actually as good as it gets. On this problem, we're doing f plus g of negative 1, so I need to do f of negative 1 plus g of negative 1. I'll do those separately, then I'll just add them together. So f of negative 1, that's going to be negative 1 minus 3, using that f function there. And then g of negative 1, that's going to be, and I'm adding all this now in a parentheses, that's going to be negative 1 squared minus 3 minus 2 times negative 1. At this point, it's going to be time to simplify a little bit here. So let me see here. First parentheses, this stuff, I can simplify to negative 4. And this stuff over here, this is going to be, let's see, negative 1 squared is really just 1. And negative 2 times negative 1 is positive 2. So we really have 1 minus 3 plus 2. Now hold on a sec. 1 minus 3 is negative 2. Plus 2 just gives us 0. So at the end of the day, this is just negative 4 plus 0, which is just negative 4. On this one, I'm doing f minus g of negative 3. So f of negative 3 minus g of negative 3. F of negative 3 is 2 times negative 3 squared minus negative 3. All that stuff there. Notice I'm using parentheses on the negative 3 so that I don't lose anything. And then I'm going to have to subtract from that g of negative 3. So I'm subtracting in a big parentheses negative 3 minus 1. Time to simplify this a little bit. So over on the left side here, we've got negative 3 squared. I've got to do the exponent first. So negative 3 squared is 9, times 2 is 18, and then negative 3 is plus 3. Over on the right side, we've got negative 3, which is just 3, minus 1. So I've got 21 minus 2, which is 19. For this problem, I'm doing g times h of negative 2. So that's g of negative 2 times h of negative 2. G of negative 2 is going to be negative 2 plus 3. I'll put all that in a little parentheses just to keep it together until I'm ready to do something with it. And then h of negative 2, that's negative 2 substituted for all these a's in the h function. So negative 2 squared minus 5 times negative 2. And again, all that I'm putting in a nice little bracket to keep it separate. Time to simplify a bit. This first bracket here, negative 2 plus 3, that's just positive 1. Over in the next bracket, we've got 4 plus 10, if I simplify both of those. So we basically have 1 times 14, or just plain old 14. On this one, I'm doing g over h of 10, so that's g of 10 divided by h of 10. G of 10 is 10 squared minus 10. That's just g plugging in 10 there. And then h of 10, plugging 10 into this h function, we have 4 times 10 plus 2. Now I can simplify a little bit. Up top, we've got 100 minus 10, which is 90. Down below, we have 40 plus 2, so 42. A grand total of 90 over 42. Now, we can do a little bit better than that. So it turns out we can divide both of these by 6. 90 reduced by 6 would give us 15. 14 reduced by 6 would give us 7. So 15 over 7 is as far as we can go on this.